Good morning. Welcome to RenderATL, everybody. It's good to have you here. Hopefully, if you haven't already, head over to my GitHub. The first pinned repo should be this TypeScript workshop. Clone or fork if you want to actually do some work and save it for later. Fork it if you just want to use it as a scratch pad and code along and just throw it away at the end of the day. Cloning is fine too. This is going to be 99% live coding. Following along, you guys can do some coding. There's just a tiny bit of slides just to sort of introduce some ideas. That's what we're going to start with here. These slides will not take long, and then we're going to jump right into some code. All right, let's keep this really short. If you go to the README in the Google Doc, or excuse me, in the repo, I've got these links here. So here's the repo, which you should have already. All these slides are linked in the README as well. All right, some quick TypeScript introductions. TypeScript is structurally typed. It's not nominally typed. Has anyone ever heard that, structural typing, before? Anybody hear that phrase before? It's actually kind of unique. There's not many languages that are like that, and I'm going to sort of show you what that means in a second. TypeScript builds on top of JavaScript. It's just sort of a thin set of typings that we bolt onto JavaScript to give us some type safety. Nominal versus structural typing. It's really, really important that we understand what this means. So nominal typing, that's what every other programming language that I've ever heard of is. Java, C#, C++, whatever. Structural typing is the weird one, and that's what TypeScript is. And I'm going to show you what that means in just a second. But it means we just care about the structure of a type. We don't care about the name of the type itself. So has anyone here ever coded in any language other than JavaScript or TypeScript? Any C#, Java? Cool, great, awesome. So here's C#, and we could probably sub in Java and it'd be pretty much the same thing. So we have this class point and this class point2, and you can see they're pretty much identical, but as far as C# is concerned, they're totally separate. So if I declare a variable of type point, this here would be a compile error if I uncomment it. I cannot assign a variable of type point to point2 since they're different types. It's like common sense in any other language, but in TypeScript it's fine. In TypeScript you totally can do that. TypeScript is like, well, this is of type point1, it has an x and a y that are numbers. Yeah, point2 is fine. It's the same structure. You can assign them back and forth. Totally fine. And that's so much of TypeScript is built around that. In TypeScript, the types come after the variables. So like if you've coded in C# or Java, we'll usually put the type up front. We'll say number x equals whatever. TypeScript, it puts it trailing after the variable name. And that's for a few reasons. It helps interop with JavaScript, and also it helps us add type inference. Because we can just leave that type annotation off, and it still works. And TypeScript will infer the type based on what you assign it to. And that is what the sort of trailing types allow. Other programming languages do have inferred types. They usually do it by creating a new type that means infer. So like in C# you have var, which means infer the type, or C++ has auto, and so on. The last slide is the most important one. TypeScript's your friend, and take this advice back to work with you. If you can't figure out how to do something in TypeScript, don't just suffer forever and don't be miserable. Just use any. It's okay. The perfect is not the enemy of the good. Please feel empowered to just use any if you can't figure something out. Try and learn it later. Try and improve your skills, but don't let TypeScript block you. Don't let it make you miserable. TypeScript should make you happy. TypeScript should help you write programs that have fewer bugs. It should catch your errors much sooner. And that's that. Game plan, I've got 5 modules. I thought I had 5 hours. Turns out I have 3. We'll see how that goes. Sometimes I'll have some quick slides, and then we're going to run through some code. And I'm going to live code some stuff up here. If you're curious to see where the lesson plan is going or what I'm about to do, there's an instructor reference in each module. That's all the code I'm going to write. And if you want to just look ahead, feel free. And then I'll have some exercises on these modules that you can code through if you want. Some of them will be easy, depending on how much experience you have. Chart your own path. Obviously, if there's something else that you want to learn from TypeScript, feel free, hold that question. I'll be sure to try and make time for it. And again, use the exercise time however you feel best. Feel free to not do the exercises. If you want to just look at the instructor reference and poke around at that, that's totally fine. Second to last slide, if you want to learn more after you leave this course, these are the 2 best TypeScript books I've ever seen. They are superb. Read them in that order. The one on the right is much more advanced. And lastly, anybody here have like an education budget at work where they'll let you just buy shit and then like expense it? This course is really, really good. It's not cheap, but it's really, really good. It's by Matt Pocock. Superb training. I urge you to check it out. Again, it's not cheap, but if your employer is going to pay for it, check it out. All right, that's it for the slides. Now let's do some code. Hopefully everyone has the repo cloned. I am in the module 1 folder. I just opened that folder directly. You don't have to do that. Peek ahead to the exercise. Hopefully you have red errors everywhere. Hopefully down here, if you open this up, you'll see a bunch of errors, and hopefully you'll see a bunch of red squigglies. If you don't, raise your hand. That's a small problem, but we can overcome it. I think VS Code ships with TypeScript built in, so we don't have to npm install anything. So I think we're golden. All right. Oh, last question. Raise your hand if you're like a total TypeScript noob. Cool. All right. Awesome. Raise your hand if you're like middling skills, like you've been around a little bit. Okay. Any advanced TypeScript people? Good. All right. Might be in the wrong room. Hopefully we'll have some material here for you too. All right. So we're going to start at the beginning. We'll move briskly, but I don't want to assume any knowledge. So in JavaScript, we can create a variable, let s equals hello. This is also valid TypeScript, and like I said, TypeScript likes to infer types whenever it can. It's going to be very, very helpful. And when we do that, boom, s has a variable type, even though we didn't give it one, and it has a variable type because we assigned it a value. If we leave off the assignment, there is no inferring, and now s is going to be any, which is not good. For now, we'll leave it as a string. And now if we try to assign a number, TypeScript can say, hey, that's not valid. Type number is not assignable to type string. And let's close that to get rid of those. There's other types. It's JavaScript. The typings match JavaScript's types. So we have Booleans, as you'd expect. We can give it a true if we want. We have numbers. Let n as a number. And now we have some weird types. Any is our escape hatch. If we ever can't figure out anything, any just shuts off the typing completely. Now anything goes. We can assign a to a function. We can just write code that will blow up immediately at runtime. And TypeScript is like, hey, whatever, that's cool. You do you. And now we get a little bit weird. TypeScript in the last year or two added this unknown type. Unknown is like a root type. Anything can be assigned to unknown, but you can't ever really use it. You can do very minimal things with unknown. You can like check for equality, and that's about it. You cannot compare these values. You cannot, if I could type, you can't do something like set a property on it, because TypeScript's going to be like, well, the error message is not very helpful, but it's an unknown type. It's basically a placeholder. If you don't know what type you want, you would say unknown, and any type can be assigned to that. But before you use that variable of type unknown, you'll have to cast it to something. And we're going to get into all that in a bit. And lastly, there's this really weird type called never. That means that's just an invalid type. It will never exist. We're going to see some fun uses for that later. All right, anybody know the difference between a function declaration and a function expression? This is a JavaScript thing. Raise your hand if you know what those terms mean. A few people? Okay, cool. This is a function declaration. and this is a function expression. So function declarations, we say function and then keyword, and then the rest of the function body. Function expressions, we declare a variable, and then we assign it to a function. And it can be an arrow, or in theory, we could write the word function here, and that's an expression. This distinction doesn't usually matter. There's things like hoisting, whatever. But for TypeScript, it's actually kind of significant, and I'll show you why in just a second. Let's talk about return types to functions. Let's say we have this function foo, and it doesn't return anything. So again, TypeScript's pretty smart. It can infer that it returns nothing already. And the way we signify nothing in TypeScript is with void. And that's nothing for a return type only. We can't just declare a variable of type void. That's not valid. We can't say let f of be of type void. No, I guess you can, but you don't. Void is for return types for functions. And that's how we put a return type on a function declaration, right after the parentheses, colon, void. If you want to, you don't need to. Sometimes we want to explicitly say that a function returns a type. That's how we do it for a function declaration. For a function expression, it's the same thing. Right after the parentheses, you put the return type. Why am I telling you this? We'll see one difference between them in just a second. Let me make sure I'm not leaving anything off. All right, let's say we want to have a function that returns a number. Again, same thing. We put the return type there. If we put the wrong return type, TypeScript will yell at us, say, hey, this function returns void, but you returned a number. That's wrong. And for function declarations, it's the same thing. I know this first module is a little boring. We just want to get through some fundamentals. And if there's ever any questions, please don't ever feel hesitant to ask. All right, let's write a function that takes some arguments and does some stuff. Let's say a function called +1. Oops, I'm getting ahead of myself. Just a silly function that takes a number and adds 1. TypeScript's yelling at me. It's saying parameter val implicitly has an any type. There is, in theory, a setting where you can shut that off and just say, hey, I'm OK with implicit any, but we shouldn't use that. Make sure everything has a type. If you ever want to make something any, you can cast it, or you can type it as any. But by default, TypeScript is going to expect you to type some things. So how do we add a type to a variable? It's exactly what you would guess if I made you guess. You just add the type just like we do with variables. And now val has a type, and now we can return a value from this function. And we can add the return type as well if we want. This is the return type for the function. This is the type for the parameter. And let's do a function expression as well. And I promise this will make sense why I keep mentioning function expressions versus function declarations in just a second. And anybody know what REST arguments are in JavaScript? You've probably used them a million times, even if you don't know what they're called. Let's say we want to create a function called logAll, and it's going to take a bunch of we're going to take arbitrary args in it, like this, and we're just going to log them all. So this is not TypeScript. This is just straight JavaScript. And what that means is I can just pass an arbitrary number of arguments to it, and JavaScript will just gather whatever args I dump into this function, and it'll put them into an array like that. And TypeScript's yelling at me and saying, hey, right now this is an array of any. We give it a real type like that. Notice the square brackets here. We're saying that these rest args are going to be an array of strings. If I pass anything other than a string, TypeScript will yell at me. It's going to say, hey, type number is not assignable to parameter of type string. What if we want to change this log function so that it takes numbers, or strings. Now we're going to look at something new. We're going to do it like that. So this single pipe here, for now we're just going to think of that as or. This is how TypeScript says or. So we're going to say this is an array of strings or numbers. Really, it's a type union, and we're going to talk all about type unions in a bit. But for now, string or number. And now we can call this new function, and we can pass numbers or strings. We can create our own types. We can say type bool for some reason equals, this is pointless, but you can create your own type that's nothing more than Boolean if you wanted to. That's pointless. Really, we want to make our own type that's something different. The first type I'm going to show you is making a type for a function, and that's going to tie in with what I just showed you. So let's say we want to make a type that is two strings, return a number. Here's how we create a type for a function. First, we tell it what arguments it's going to take. We'll say a couple of string arguments. And then how do we specify the return type? Based on what I showed you, you might think it's like this. It turns out it's not. When we're building a type for a function and we want to specify its return type, we do it like that. So now this type can hold variables that are functions that take two strings and return a number. And real quick, let's create a second one, log two strings, and it's going to return a void. All right, how do we use these types? Let's say I have a function that takes two strings and it returns their length, the sum of their lengths. This is a pretty pointless function, but and this returns a number. Let's just specify that. TypeScript can infer that it returns a number, but let's just specify it explicitly. If I want to say that this variable is of type two strings return a number, it's exactly what you would think based on what I told you before. Just like any other variable, we just slam that in there just like that. But here's the cool thing. When I do that, I no longer have to specify types for the parameters. Because I said that this variable is a function that takes two strings and returns a number. So TypeScript already knows that. It infers that based on the type that I assigned it. And it also knows the return type. I said that this function needs to return a number. If I switch this to return a string, TypeScript's going to scream at me. It's going to say, hey, val string, returning a string is not assignable to type two strings, return a number. Type string is not assignable to type number. So I get rid of those quotes. So this is where that distinction comes in between function expressions and declarations. If I wrote this same function the old school JavaScript way, like that, there's no single way to apply a type to a function declaration. I cannot do that. That's not valid. TypeScript yells at me. I don't know why it's not supported. It would be nice if it was, but it's not. So you might see advice in TypeScript that you should prefer function expressions. That's why, because you can just slap one type onto a function expression, and then TypeScript will infer all your parameters and your return type. Not even infer, it'll assign all your parameters and your return type to a type based on that. How are we doing? Any questions so far?
Is it common practice to make your own function types like that?
Yes.
Yeah. Are you often looking them up to see like, well, what the hell is this type? Or is it just good practice to make it very explicit? Your names there are very explicit.
No, you would never name your functions based on the arguments. It would be like a accounting result. I don't know.
I got you.
Name it based on what it does. These names are just to show you what they're doing. Good question. Thank you. All right.
What's the point of const? Just a syntax question.
Const?
Yeah, why?
That's just JavaScript. That just means that the function can be reassigned. So I can declare it as let, and then I can just reassign that function to something else later.
Okay, so you're effectively just
Yeah. That's JavaScript.
Equivalent to let?
Const?
Yeah.
No, so if I say const x equals 12, x can't be reassigned now. I can't say x13. But if I say let, and that's not a TypeScript thing, that's a JavaScript thing. If you actually run this code, this code will blow up at runtime. Yo.
Yes, sir. So this question is kind of more like using it within React. So if you use a declarative function, I guess to create your React component, can you still use single type for multiple values? Let's say if you have props, which destructure those props, you can still use a single type.
Yes, definitely.
Using a declarative function, right?
And I'm going to show you that in a bit. That's, yeah, module 4. Yeah, don't worry, we'll definitely get to React.
Okay.
Any other questions? Yo.
Will you reuse these definitions like at scale if you create consistent type definitions? Will you reuse them for multiple different functions?
Oh, definitely,
Is
yeah.
that one of the benefits?
And you can export types too.
Right.
So export type, and then you can import it later. All right. Types can be combined. You saw this before. Bool or string. And now we can declare variables of type bool or string. And we can assign this strings, or we can assign this Boolean. This is going to be relevant a bit later. We can declare types that hold nothing more than an explicit value. So look very closely at what I'm going to type here. I can say type. You normally want to name your types with capital letters. Type yes equals the string yes. This is not a variable of type string that holds yes. This is a type. The type is called yes, and the values that it can hold is the string yes, and that's it. So like I can say let y of type yes, y equals, that's all I can assign it. I cannot even say capital yes. I cannot say y equals anything else. Anything other than that single string is going to be an error. And that's going to be hugely important when we talk about discriminated unions in a little while. And we can declare types that combine values. We can say type yes or no equals the string yes or no. So there's that type union again. Before I did a union for Boolean or string. Now I can do one for the type yes or the type no. And I can declare variables of that. Let y or no. I can assign it and type, and look at the VS Code IntelliSense. It's smart enough to know the valid values, and it's giving me those as choices. And if I give it anything else, TypeScript will yell at me. Let me make sure I'm not leaving anything off. Boom, 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 boom. All right, home stretch. Here's something you're going to use a lot with React. You can declare types that are objects. And this is matching a lot closer to things that you've probably seen at work. Here is a type that's going to hold an object that has this structure. And now we can declare variables of that. We can say let some object of type some object. Again, we declare a variable, give it a trailing type, and now we assign it. And TypeScript is even going to be smart enough to say, hey, here's your properties. Go nuts. like that.
Struct and see.
Like a struct in C, yes. All right, let's say you have some object in JavaScript, some object of default values or some configuration object that's important. Let's say we have something like this, and we've got a title. Maybe this is like a Redux default state or whatever. And let's say we want to pass in values that match this shape. It's so nasty and boring and demoralizing to have to like duplicate all this stuff and say, well, okay, string active is Boolean, count is a number, just to match these up, right? So let's say I wanted to take a variable that took this. I have to make up a type just to match this. TypeScript gives you a neat little trick to avoid having to do that. We can say instead type default state equals type of default state. And now default state is exactly what I wanted there. That's hugely useful. That's a really common thing. If you have some variable and you need to pull the type out of what that variable holds, type of variable will just switch that over to whatever its type is, and you can assign it. And now we can use this default type or default state type as function arguments and such. All right, home stretch on this first module. Let's say you wanted to just pull the type of this title. Obviously, it's a string, but just imagine it was something with lots of stuff in it. It's this big structure in and of itself. Yeah, whatever. How do we do that? And I hope it's clear what I mean. Like, pretend this title thing had a bunch of stuff in it, and I want to, the type of thing, I want to pull the type out of it, like I did here. So, being JavaScript developers, just to be crystal clear what I mean, that's what I'm looking for. But I don't want a type string. I just want to point TypeScript at this property, and I want it to pull that type out, which is string, because I don't want to type string, because it might not be a string, it might be something really complicated. If you've ever coded in C++ or Rust, you could be forgiven for thinking it was like that, but it's not. As a JavaScript developer, you would be forgiven for thinking it's that, but it's not. This is actually old school TypeScript namespace syntax that you'll never use directly. In reality, it's like this. We use an index type. We say, take this type, throw some square braces around it, and add a string, and that's going to pull that type out. And so now default state title is a string without me needing to type it.
You don't need type of in that.
No, because this is a type here. You are right. In this particular case, I could have also said type of default state dot title. That should be fine. But that's only because I had a variable of that type. Just pretend you just built this type yourself, and you don't happen to have a variable of that type. That's how we do it. And we can do some really neat things with that, with these index types. So generics are coming later, but I just want to give you a sort of peek at some of the cool things. We can create types that are basically indexes of another type. We can say type key of default state equals key of default state. And so now if we look at key of default state, it's created a union for us holding only the keys that default state can hold: title, active, or count. And we can create a variable of that type. We can say let k of key of default state. And now TypeScript is going to be super specific about what we assign to it. It can only take something that's a valid key. And lastly, oh no, not lastly, we have tuple types. And then we're done with this module. A little bit of foreshadowing, a little bit of the stuff that we're going to look at later. But let's just do something a little bit crazy. Let's say type of default state. Let's just peek ahead at some of the power that TypeScript gives us. We can just manually grab the type of one of a type's members by manually passing the string in. Let's create a factory that does that for us. Let's create a type that takes in one of its keys and just spits back whatever the type is. And we'll, for now, we'll introduce a generic type without saying what it does. And we're going to say t extends key of default state. Equals, and I'm running out of space here. Oh, here, let's create some space. So I can create a type that takes a generic argument, and I'm going to say, hey, this t is going to extend key of default state, and I'm going to assign it like that. And so now I can say something like type count type. And look, it even gives me autocomplete for the generic type, like that. And don't worry, I'm going to explain all this in a bit. This is just sort of a foreshadowing, just sort of a peek at some of the more advanced things. All this stuff will be explained in detail. I just want to sort of give you a look ahead at some of the powerful stuff TypeScript lets us do. Don't worry about whether you understand this extends. I promise I'll be teaching that very soon.
I'm sorry, can you explain key of one more time?
Yeah, so key of, it takes a type that's an object, and it spits back a union of all of its keys. So default state, I'm sorry, I don't have a lot of vertical space because I had to zoom in so much. Where is default state? OK, so unfortunately, type default state is defined like that. Here, let's reduce the number of, let's do it like that. Let's do it like that. OK, so I've got default state here. And now I'm saying type key of default state equals key of default state. Oh, come on. Your TypeScript is like, hey, what is this type? Well, it's key of default state. I know, I just said that. But if we want to see what it actually is, we can do something like k of default state. And those are the valid values it can take. Good question. All right, last section in here, and then I'd be happy to answer questions. I hope I didn't move too fast. Then again, we only have 3 hours, so maybe I didn't move fast enough. All right, let's say we want to hold. Does anybody know what a tuple is? It's an array of values. Here's how we build it. First of all, does anybody know the difference between these two types? Oops, sorry, like that. Anybody know the difference between these two types? Anybody? Yo. Oh.
Sorry, I'm chewing. The first one could be an array of any length. The second one, I think you can only have, it has to have 2 items, a string and a number, right?
Yeah. So the first is what it says. It's an array of strings. takes just an array of strings. Or it can be empty. Arrays can be empty. And it has all the array methods that you know and love. And so on. The second one is much more limited. It takes a string and it takes a number. And if you don't adhere to that contract, type array of single string is not assignable to type string or number. Source one has one element, but target requires two. OK, I'll give it a second one. Still not good enough. It needs to be a number. Type string is not assignable to type number. Oops. Like that.
For the second type, does order matter?
Yes, order matters. It has to be string and a number. We still have some of the methods that we talked about. You can do things like filter. The members will be string or number. And look at that. It gives you a 0 or a 1 member, like that. Do you remember up here I said, hey, I want the default state, the type of this title member, and I said default state square brackets title. Anybody want to venture a guess how I get the type of this first member? Bracket around what, specifically? Be precise.
String and number.
Nope. Yes, number 0, whoever said that. Type first member equals string and number 0. And that is going to be string. Yeah. That's what I wanted to cover. Any questions about that?
How would you make a type that's an array of a union of types? Like a variable length array of string or number?
Yeah. I showed you that above on the rest args. Type string or number array equals string or number, like that. So we want a type union of string or number, and then an array of that. TypeScript builds on it nicely. Yo.
Can we go over the key of section again?
Sure.
That's the only part I'm not.
Yeah. So here it is, isolated. We can create a type that's this sort of structure, this object structure. It's got some properties. And then we can create another type that represents only its valid keys. And what does that mean? It's a type union. It's going to be a union of, I wish it showed what it was.
Should we think of it like object.keys in JavaScript?
Kinda, but this is going to be a union.
So it's just the keys, not the type of the keys.
Right, exactly. It's going to be literally this. It's going to be a union of these 3 strings. It's going to be an OR. So this type is, I keep saying union. We haven't covered that well yet. There's a whole section on unions. Valid keys is the type title, or active, or count. Remember I said that you can have types that represent values. Type yes equals yes. If you create a variable of type yes, it can only hold the string yes. And it even has to be capitalized exactly like that. That's the only value in the whole world it can hold. Or it can add other values using that pipe, using that OR syntax. So now this is yes or no. And this type holds the string yes or the string no. What if I wanted a type that holds only the strings that are valid keys of this type? That's what keyof does. And I know it seems silly, like it's not something you normally do day to day, but it's actually kind of useful. And it's good for some of the meta-programming things that TypeScript lets us do that we'll be peeking at in a little bit. Anything else? Yep.
What is your opinion on using type of like this versus, like usually you describe your type and then you assign variables to that type, but here you did the opposite where you declare the variable and then you use it, define the type of that.
It depends on your use case. You wouldn't like You wouldn't say, I want to use type of, therefore I'm going to create a variable so that I can use type of. It's for use cases where you already have the variable. You've got an object that represents something in your program. You've got this default state that you need to pass to your Redux reducer, or you've got your use reducer. Forget Redux. Like if you're using use reducer, you need that initial state. You've already got that variable because you have to provide it to the use reducer hook. Now if you want to extract the type out, you use type of on that same initial state that you already have.
I feel like it will create some, you create your type of a variable, so it can create like problems in other places that uses that type, because if you add a property to that type, that variable, then it can cause problems elsewhere.
And you want problems, right? If you add properties and there's inconsistencies, TypeScript's going to say, hey, you just added a property here. Now the other places you're using that type are inconsistent. And that's what TypeScript gives you. Anything else? Yo.
So should I use typo for all the API responses that we get, or the other way around?
For all the API responses.
So if you're connecting to the API and we get the response from the API, should I use typo for
I don't
the response type?
I don't think you'll be able to. So type of is only if you have a variable in JavaScript that actually has values. So like I have the So this is like somebody forced you to build this object because you needed it so that you could pass it to use reducer. You don't, once you have this, you don't want to boilerplate retype all those stupid properties again. Because then if you add one here, you have to add it again there. So instead, we have the ability to say default state 2. So this is like I already have a variable somewhere and I need to extract the type. That's how I do it. If you don't already have a variable, don't go build a variable just so you can use type of. Just build the type. And if you have an API response, you won't have the type on it unless you're using like tRPC. But even then, type of is not what you would use there. Yes?
I was going to say, like, if you're fetching something like data and you don't know exactly the structure of your data, would this help in terms of
No.
creating a type for it?
It wouldn't. So the only way this is going to work is if you have, TypeScript has to look at it statically. If you fetch from something, there's a type coming back, and it's probably going to be any, unless you're using like tRPC. This is like static variables that you've declared and are sitting there that TypeScript can look at and infer the types out of. These are great questions. Are there any others? Yo.
I just want to point out, it's like the difference between compile time and runtime.
Yes, exactly.
From an API, that's a runtime.
Nothing you can do there.
That TypeScript isn't aware of.
TypeScript can't help you there. If it's runtime,
Look at soft.
your API endpoint has to ship typings that are telling you what those types are. Otherwise, it's just going to be any or unknown, and you're going to have to build the type yourself. Did you have a question?
I was going to say something similar.
Cool. Awesome. Teamwork.
No, no.
All right. Do we need a 5-minute break? Yeah, go. Go ahead. Take 5. Take 10. Long time ago. Ages ago. It looks nothing like it did back then. I love it. It's a wonderful place to work. A little over 2 years.
So I think, yeah. So if I do this now, so I can like play back, it'll actually show me.
Well, I should get your number and then we can go.
And then if I'm like, this thing, maybe this would be better. Because my college notebooks are just like, write something, keep writing, find out I'm running out of print and throw it away. I mean,
That is
Yeah, it's like this really big building. It has like Instagram products and they have like
Oh, that's cool.
it's really fun and they have
Polar bears. Are they open on Saturday?
it's like right next to it.
Oh,
Where'd you get that Starbucks?
I got you.
Get Starbucks?
Oh.
Fifth floor? In this building? Okay, thank you. How long of a break do we have?
What's that? About 5 minutes. I mean, if you gotta get some caffeine, don't let me stop you. Yes. In every module, whatever file, you can look at instructor reference, and that's the end result.
Do you know if there's coffee?
To do with, ask a staff member. I don't know. I got mine at my hotel.
Yeah.
Yep. And that's everything I coded. And that's what I'm in the process of live coding. So if you want to peek ahead, you can feel free. Yeah.
I can't see very well, so I'm using that and
I was born there, but I'm here I live in Why you want to go live in France?
Hello.
Sorry to interrupt.
Yo.
You just got here.
No problem.
What you guys are doing right now? If you could give me like a quick catch up on like
Yeah,
to
yeah.
know what everything's up to.
Yeah, get on Wi-Fi and I'll show you where to go.
Okay.
Maybe for web development and design, not too much for
So
anything else.
do just type Adam Rackis. Oh, sorry.
Yes, we can go there on it.
Got you.
That would be great.
Western Conference, I'm assuming.
Do you have check plugin or anything? I'd use yours.
Could we pass down the Wi-Fi sheet, the paper? He'll get you set up.
RenderATL.
All right, welcome back. Do I have slides for this? All right, everyone. This module is generics. This is where TypeScript starts to become TypeScript. This is a fun module. At least I think so. I'm kind of biased. We are going to sort of build generics up from the ground up, from first principles. We're going to write some code that's kind of stressful and anxiety-inducing, and we're going to see the value that TypeScript, or excuse me, that generics adds and solves for us firsthand. So hopefully we all know that arrays have this filter method, and you pass it in a function that takes one of the members and returns true or false, something like that. And now x is going to be typed as an array of number. It takes in an array of numbers, and it kicks back an array of numbers, and we pass in the function that runs our test. Let's write our own filter, but we're not going to write it on array. We're just going to write a freestanding function that takes in an array, and it takes in the same test function, and it returns a new array that's filtered. It's easier to show than to describe. So we'll say function filter. For now, it'll be filter untyped, and it's going to take an array of any, and it's going to take a test function, and it's going to take and let's see, const result any for const item of R if test function of item push. It's like I'm in an interview right now. All right, something like that. Anybody see any problems there? Let's see. That should work. We're not going to see if it works, but it should work. All right, we care about the types, not passing an interview here. So I've got this filter function. It takes an array. For now, it's an array of any. And it's going to take this test function. And that function is going to take one item of the array and return Boolean. And we're going to create our result here. We're going to walk the array, and for any item in the array for which that function returns true, we add it to the result and return it. The sharp among you might notice that this test only takes the item. In reality, filter takes the item and the index and the collection itself. We don't care about that. What sucks here is that this is any. We'd like to get some typing here. So we might have an array of strings. If we pass the string array like that, char, something like that, it should be an array of strings because I'm filtering this array of strings, but it's going to come back as an array of any. That's sad. All right, let's start to type this function. Let's build a version for strings. We'll say filter strings. This takes an array of strings, and now the item is going to be string as well. And that'll work. Now we can say filter strings like that, and now filter is going to be, it's going to return back a string array. OK, cool. So now if you want to filter an array of strings, you just call this one, right? Well, we need to filter numbers. OK, so we'll build a number version. Filter number, and now, well, that's not a string, that's going to be a number. That's not a string, that's going to be a number. That's a number, like that. That's a string array. Whoops, what's your problem? Type never is not. Oops, like that. It's a string array. Like that, and this was an any array. All right, and now if I have an array of numbers, oh, hello. Something's happening. Oh, good timing. We got a projector issue here. The projector went out. Anybody know how to fix one of these? Oh, it's hot. God damn, that's hot.
Just go out again.
I mean, it seems to be on.
This was flashing and stopped. There goes lamp.
Oh. Might be. It's.
Oh, I see it come back. Hey, there it is.
Yeah, but it's really dim.
Its bulb is warm.
Oh, really? Oh, it's getting brighter. Cool.
At least you only have 3 hours.
Yeah. All right, can everybody see that? All right, so we built the number filter, right? So now this takes an array of numbers, returns a number. Here's the result, number. Obviously, there's literally infinite number of these we'd have to write. Yes, there's strings, numbers, booleans, but there's also, you could build your own type. You can build arbitrary structures. We can't build a filter for each one of those. There's literally infinite number of types. All right, so what we want is, we want to build one filter. And instead of specifying this, we want to build filter as sort of like a factory, a function factory. We want to take in a type and then create a special filter just for that type. Really, I'm describing more C++ templates than generics. Really what generics are is they let you receive a type arbitrarily as sort of a parameter to the function, and then we can use it. Some people get mad at single letter generic names. They're actually common. Feel free to name this something more. I'm going to sort of be old school and just use T. You'll see that more often. It's okay if you want to use longer names. All right, so this is going to receive some type, and then we can just use it. So that we'll say this filter is going to receive an array of that type, and it's going to receive a function that takes an item of that same type. Boolean stays the same. And now we're going to declare, and we can use it inside the function in addition to the parameters. We can say an array of T. And that's that. That's valid, and that'll work. Let's see how we actually use that filter function that we just built. Do I still have? All right, let's move these down here. Let's say I want to filter the strings. For now, I'm going to say const strings filtered equals filter. Hello. Equals filter. And I'm going to pass it the string array. Oops, for now, I'm going to do this. I'm going to say, hey, I want to call filter, and I'm going to pass it string for the type. So this filter function takes a T. For now, I'm just going to pass it like that in the square brackets. And now I'm going to call the function, and I'm going to pass it its arguments, str array, and now we'll say s arrow s equals a, like that. And that should be valid. Oops, a. There we go. All right. So I built this filter function. We take in some type as a parameter, and then I'm saying, all right, now that I have this T, whatever it is, this function is going to take an array of those, and it's going to take this function that takes a single one and returns Boolean. And now, hey, I can also use that type T to declare variables. I want a new array. I'm going to walk through what you gave me, push if it passes the test. And now if I want to use it, for now, I manually specify this generic type, and then I pass in my things. And if I pass the wrong type, if this doesn't line up, if I say, hey, this is a string, I'm passing string, but I pass a number array, TypeScript's going to say, hey, argument of type number array is not assignable to parameter of type string array, because I provided string here. Those of you who've used TypeScript know we don't normally need to provide that manually. TypeScript can infer the generic argument. TypeScript can say, hey, this filter takes a type T, but whatever the first argument is, it's an array of that. So if I pass an array of strings, TypeScript's smart. It's going to say, hey, well, that's an array of strings, so I can work backwards, and I know that that is string.
What if it's an array of mixed types?
Then that's what it'll infer. And I'll show you that in 1 second. That's a good question, too. And not only that, but this function infers the variable, too. And if I provide my own type, TypeScript will yell at me, say, hey, this doesn't add up. First you gave me a string array, but this is a number now, so these types aren't adding up. If I try to provide a thing, now it's going to localize the error to over here. And again, as I said, this is inferred as a string. So if I try to use something that's not on a string, if I say .toFixed, which is a method that numbers have, it's going to say, hey, there is no toFixed on string. All right, I got the question, mixed array. What if I have an array of numbers and strings? So now mixed array is an array of string or number, I can use that just fine. I can say and the result is going to be exactly what I passed in. Who can tell me what x is going to be typed as? I'm sorry, the inner x. So who can tell me what x is typed as?
Would it also be string or number?
Yes, absolutely. Because t is inferred as, so I passed in an array of string or number, so TypeScript can work backwards. It can say, well, whatever the array type is my generic type. I passed in an array of string or number, so t has to be string or number, and that means that this item t, which is x, is going to be string or number.
This is maybe just like a JavaScript question, but like how does that test work on a string against, like is it like if you pass an a, x equal 12, if you pass an a there, I assume obviously it's false.
Well, this one is string or number, so it'll pass for that second one.
Right, but like how does it compare on the a to 12? Like it just doesn't matter because it knows the types aren't the same.
Yes, and actually, what's messed up is, I don't know if this is what you meant, but that'll actually be true for both 12s, because I used equals equals. It's not?
No, that's exactly what
Oh, then yeah, that's just JavaScript. Yeah, you're right. So if you want that sort of implicit garbage, you can use equals equals, or you can be explicit.
Random question. If the function, inner function, is trying to use like a string property to compare, would it TypeScript yell at you?
Yes.
For doing that?
Even though it's string or number, you have to narrow it, and I'll get to that in a bit. That's a good question. Did you have something? No? Anybody else? All right. Classes can also be generic. I can say class foo, and I can pass args here. And again, there's some thought leaders out there who get really mad at these single letters. They're super common. If you want to use longer names, go for it. I don't care. This is old school, and that's, if you look at the actual TypeScript code, which I'll show you in a bit, they use T as well, so it doesn't matter. Do what you like. And now I can use it inside the class. I can say property 1 is T1, and I can say property 2 is T2. And now let's build a constructor function. T1, T1, T2, T2. This dot property 1 equals T1. This dot property. Oh, come on. What's going on? Why are you being difficult? All right. So I've got this foo here. Like before, I can say let f equal new, just like JavaScript foo. For now, I'm going to manually specify, we'll say string, number, and now I need to provide a string and a number, like that. Who thinks, so the question is, can I delete that? Who thinks that it would be valid for me to remove it? Who thinks it would not be valid for me to remove it? Whoever said it's valid is right. It is valid. So if you remember before, I said that TypeScript can look at the function, and it can look at the function arguments and work backwards to figure out T. TypeScript will do the same thing with classes using the constructor function. Because when I call new, this is what gets called. And so it can look at those arguments and work backwards just like before. But that only works if you're actually passing in arguments for all of them. If I have some T3 and like that. Now, oh, okay, it's still valid, but TypeScript is going to fill in unknown. But in general, TypeScript will still do the inferring, but you can always pass them manually if you want. All right, I have another thing I want to walk through with you all. I have not explicitly told you about interfaces, but it's pretty much like a type. Like I can say, I can do this. And it's pretty much the same thing, but interfaces let us do the extends, which does exactly what you think it does. It's just like classes can extend from each other. So this interface takes an artist, it takes a catalog item, and it adds some extra stuff. Okay? So I work for Spotify. This is code that's very loosely inspired by some Spotify code. Let's say we're managing all sorts of catalog items. We have artists, albums, songs. You might assume the Spotify data model is a little bit more complicated than this. But for us, we'll say every catalog item is going to have an ID. It's going to have some URL and then some metadata. And this just means an object. Don't worry about record. And now I've got an artist, which extends catalog item and it adds a string. I've got an album, which extends catalog item and it has a name and a track count. And I've got a song that adds a name and a duration. And yes, name could have been up in the base interface, but then artist would be empty. So whatever. We'll keep it like this for now. And I can create a variable, name it artist, and give it the structure that it wants, and that's perfectly valid. Whoops, hang on, give me 1 second. Yeah. Okay, so here's our mission. Here's what I want to walk you through. I've got this function, get similar items. It takes an arbitrary item, which is any catalog item, and it returns an array of similar items of the same type. For now, we're just hard coding it. We're just going to take the same item and just duplicate it a few times. In reality, this would be asynchronous. We'd be returning a promise. We'd hit some endpoint. We'd do all this other stuff. But for now, because we want to focus on TypeScript, I'm taking an item of this type, and I want to return an array of that type. So you might first think that this is going to be a really great solution. And it seems good. This seems like we're on the right track, right? I've got this artist object. And I'm going to name this get items 1. And I'm going to say result 1. Don't worry, and by the way, those yellow swigglies you'll see, it just means I have a local variable I'm not using. Just ignore those warnings. I tried to figure out how to shut them off. I couldn't find anything. Who can see the problem with this code? It's a very subtle problem, but this code is not great. I mean, it's not great for a lot of reasons, but as far as the typings go, can anybody sniff out why this isn't good? I'll give you a hint. Look at what we're passing in, and then think about what we're getting out. Yo. Which interface? Where? The name is, oh, no, don't worry about that. that's not a part of catalog item. I just added it to all the others.
Right, but if you're passing an artist,
Uh-huh.
artist, there's no name.
Yep, it's right here.
Okay. Like interface that you like.
Oh, so this artist interface, it extends catalog item.
Got it.
So we get all of this for free.
Cool.
Is it that all of the interfaces have a name property?
Nope, that's fine. So remember, whatever type I pass in here, I'm getting the same type back. So if I pass in an artist, I'm getting an array of artists.
Okay.
If I pass in a track or a song, I want to get an array of songs. So with that, can anybody see what the problem is? Yeah. So I've got some type erasure going on here. So I'm passing in an artist. I want to get an array of artists back, but I'm getting catalog items. And that's where generics are going to come in to play. I do know how to do this without the notes. I just want to make sure I'm not leaving out any intermediate steps that I want to teach you. All right. So did I want to do that? Yeah. So we'll call this get similar items to, and it's going to take a generic argument, and it's going to take our item of type T, and it's going to return an array of T. And again, for now, we'll just do item a few times. So this is looking much, much better. And now, call the right one. Now the return type works. I pass in an artist, and I'm getting back an array of artists.
In the first broken one, it's returning a catalog item. Does it just strip the name property, all the extended properties then?
It depends on what you mean. Like whatever you pay, it's still there, but TypeScript won't let you touch it. But
It's not that type anymore.
right, but in memory, it's still there.
I got you.
You'll have to typecast or do an any or do a tsignore, but the property is still there and it would still work. There's another subtle problem with this. Can anybody see what's wrong with this? Well, I guess I haven't really defined. Well, I guess it's in the directions here. So here's our prompt. Type this function. It takes in an arbitrary item that's a catalog item, and it returns an array of similar items of the same type. I've broken my contract here very subtly. Can anybody see how I haven't quite followed the directions here?
It's not filtering things of the same type?
No, we can pretend it does. I'm returning them back in reality at a hidden endpoint. Yep.
We're taking in a catalog item, but technically the similar items don't have to be the same type of catalog item based on that definition in the prompt.
Oh no, they do have to be the same, and they are the same.
I mean, isn't T just straight up anything?
Yes, that's it. So, what?
Can you repeat the answer?
Sorry?
I didn't hear the answer.
T can be anything. So I said this function only takes catalog items. I can just say let object equal just some crap here. And I can call, I can just dump whatever I want into this function. And TypeScript's like, YOLO, here's an array of that. But I want this to only be catalog item. So I can't do that because it's not going to quite work right. So what I need to say is this generic type T has to be of type catalog item. And the way that we do that in TypeScript is with extends. And now when I do that, now that errors out. Argument of type blah is not assignable to parameter of type catalog item. So now this, whoop, what did I just press? Stop it. So now this function, and now I can drop the 2. This is our final form. This is what we were driving towards. This gives us the best of all worlds here. So when we have a generic argument, if we want to filter it or narrow it or limit what it can be used with, we throw an extends after it, and then we put a type after that we need that type to extend from. Okay, this was the part where I had some in-class exercises for you all to do, but we only have 3 hours here, and there's a lot of other cool material. So what I am going to say is to take a good 10-minute break, and then let's come back, and let's press forward with the other modules. And if there's time at the end, you guys can work on anything you want, and I'm happy to answer any questions. But I do want to get your money's worth on the content I have for you, because there's some cool stuff I got that I want to get through. All right, so come back at 11:35, and I'll see you then. Yes?
Can I ask you a question on break? 'Cause I took
Yes, no problem. What's up?
I don't need a break. I missed where we discussed the carrot T and what that refers to.
Sure.
And I think that has me lost for the second portion.
Yeah, it will.
So can you explain this section?
Yeah. So you want to come up to the front? Let me get on my computer. No, you just.
So I didn't see it in the notes either.
So this is what we started with. So we had these functions. We wanted to do the same thing, but the only thing that changed was the type that we passed in.
Okay.
And we want to be able to pass any type in and do the same thing, no matter what the type is. And that's what the angle brackets do. We can say, hey, this function takes a type as a parameter itself. This is a new type parameter for filter. And no matter what we pass in, the first parameter is going to be an array of those. The second parameter is going to be a function that takes one of those.
So a capital T is just any type?
Any type. And it can be any. You don't have to use
Is it
T.
synonymous with any?
It's any. It's a placeholder for any type.
Okay.
And T is just a variable name. And it's the same variable. You can name it anything you want. You can name it foo, bar, and we can.
Okay, so we don't have to declare that first, though.
Right. You declare it like this.
Like that is declaring it.
Yep.
Okay.
So
But in doing that, that is basically like how you do the colon any. That is what that is. Like it is an any type, so you don't have to declare T colon any.
So the thing that's important here is this isn't a variable. This is a type. So this represents a type.
By way of being in the bracket.
Yes, by way of being in the bracket. It could be string. It could be number. It could be some type with properties on it. It can be an array type, a tuple type, and we've declared that there is some type T here, and this array we've decided is an array of them.
Okay.
This test fn is a function that takes one of them, and the return type of this function is an array of them.
So if once all of that happens, once you enter in your variables, like once the function is being used, are they then that consistently, or are they anything every time that you visit it in the array?
So this T becomes something when you call it.
Okay.
And so we call it down here with this string array. And so when we pass the first argument of string array, TypeScript sees that and it can work backwards and it knows that this is now a string. And so now...
And is it a string thereafter, though? Or is it just a string in that one instance?
Just that one instance.
Okay.
So this is like a blueprint for a function.
Okay.
It does what it does for any T. And so here we called it with a string. Here we called it with an array of mixed items between strings and numbers. And we can call it with anything.
Okay. Okay. I think I got it.
Cool.
At least to the point.
Awesome. Yeah, my pleasure. Hey, where's the bathroom?
Go straight down.
Thank you. Thank you. Thank you.
Yeah, I would say I would have to change the interface. So are you getting, okay, so you're not getting it from like the API or anything, right? You're just getting it from like a user.
Yeah, like I'm getting a query structure, and that structure is very strange.
Okay.
So it's because like department could be like, department can equal like and department could be lab. So then I have to just, right,
So it can be arranged.
yeah. Well, actually, it always has to be arranged.
Okay.
So then it's like, well, what if it's not arranged? Well, I already have some logic in there that basically says don't create this variable if it's and then it's like, it's still good. But I don't know, maybe it's because it's pretty cool. But I feel like I have to do like this, and then it's like, okay, now I'm happy. It's basically like, because you can like, I thought I had to know that it's not gonna get different, but if not, it must be, but I feel like I don't, because when I feel like, it's like, I feel like there has to be another way. I was sure if I can, but I don't have
All right, welcome back, everybody. I have some slides on this one, about 5 or 6 of them. They won't take long, and then we will be back in code. This section's all about unions and intersections, and I know that seems silly. Unions are just that single pipe, and it just means or, and that's simple, and what's there to talk about? It's actually, like, there's a lot, and it actually gets really complicated when you stop using just like string or number and you start trying to do interesting things. And we're going to talk about that. TypeScript structurally typed. Hopefully you already knew that, because I told you that about an hour ago when we started. We talked about how a variable of type foo means nothing more than the variable has the same shape as foo. It doesn't matter what it was declared as. Let's talk about unions and intersections. Let's say we have some cat type that has name and has some whiskers property, and then some dog property that has like a name and some Boolean for whether it's obedient. Cats don't have an obedient. It would just be false all the time. And then we have cat or dog and cat and dog. That last one's new. The and, that just means the opposite of or. That's an intersection. Cat or dog versus cat and dog. It's very, very important that we think about these in terms of Venn diagrams. of what the variable can hold. So let's say the yellow on the Venn diagram are all the variables in your code that look like a cat. They have the name and they have the whiskers property. And then the blue side are all the variables in your code that match the shape of a dog. They have the name and they have the obedient property. When we say cat or dog, that's what the line is, it's or, we mean any variable that's anywhere in that Venn diagram, either cat or dog or both. If we type something as cat or dog, we can assign to that variable anything that matches the shape of the cat or the dog or both. And similarly, if we say cat and dog, we only get that sliver in between. Sorry, I should have colored that something different. That seems obvious, but it's important that you think about it that way. Think of types as the universe of values that match that shape. That's a crucial concept to really internalize, and we're going to see exactly what that means and what the implications are in just a minute. And that's my last slide. Let's look at some code. This is our starting point. And if you're curious what this export default null is, that's just, don't worry about that. Otherwise, everything in here is a global variable now, and if I've declared a global variable elsewhere, I get problems. All right. This is what we started with on the slides. We have a cat type, and we have a dog type. This is one of the most, yes?
Is there a chance to pull up the text?
Oh, sorry. I had it before. I had a question up here. That's about what it was before, right?
Yep.
Can we see it in the back row?
Yep.
All right, cool. All right. This is one of the most, this causes so much confusion. And I have seen senior engineers not understand this. If I have cat or dog, see this variable type that's of type cat or dog? They say, well, it's a cat or dog. It's both. That means I can say cat or dog. And if I say dot, well, I'll have a name, I'll have a whiskers, or an obedient. But if I do say dot, all I have is name. And this drives people crazy because they're not thinking about it in terms of that Venn diagram. As far as TypeScript is concerned, this could be a cat or it could be a dog. It doesn't know which. So the only thing it's going to let you access are the things that it knows are there. No matter what, there's going to be a name there, and that's it. It's not going to let you access whiskers because it's not safe to do so, because this could be a dog, in which case that wouldn't exist. And in JavaScript, that would be fine. It would just be undefined. But this could be a function. It could be an object with nested properties. If TypeScript lets you access stuff that might not exist, you could get runtime errors. And that's the whole point of using a type system, is to prevent runtime errors. And then cat and dog, we've told TypeScript it's both, so it'll let us use both. And now we get everything. Type intersections are a lot less useful. They are extremely useful sometimes, but in terms of what we're going to be talking about, we're going to focus on unions. And I'll show you type intersections in the next section. Okay, so how do we deal with this? So let's say I've got this function, and let me just make sure I'm not skipping anything. I should have pulled this up before we started, sorry. Again, this is just to make sure I don't skip anything. Oh, I'm in the wrong module. Come on. Unions, source. Nope, wrong. Okay, cool. All right, so I've got this function, and it takes an animal, and the animal is cat or dog. And we've already seen, if we say animal, all we get is name. Well, it might be a cat or it might be a dog, and I want to do stuff with either based on what it is. How do I check if it's a cat and then use it as a cat if it is? There's a few ways I'm going to walk through. So for now, I'm going to show you a JavaScript function or feature. I'm going to show you a JavaScript thing that you may not have even known existed. Anybody know what I'm going to say? The in operator. So this is pure JavaScript. I can check to see if a property exists by using in. I can say, hey, let's see if this is a cat. How do I see if it's a cat? Is there a whiskers property? In animal. Again, I want to stress this is JavaScript. This is not TypeScript. Pure JavaScript. You've never seen it because you've never used it, but it's JavaScript, and TypeScript is wired to understand it. If this whiskers property is in the animal, inside of this if block, TypeScript will narrow my variable to be a cat. And now I can say animal dot, and I get the same name as before, but now I have whiskers. And I want to be crystal clear. This is not, well, I always have the name type. Now TypeScript knows there's a whiskers, so now it'll let me use whiskers. It's a whole cat. So I can say like a cat breed, and now I have access to the cat breed too. I've got everything. Inside of this if block, animal is now a cat, else, that's all that's left is dog, and I get, it's now narrowed it to a dog because there's no whiskers. So we're done, right? That's it. We just find the property, use in. This is actually a terrible solution. It's awful because this just happened to work because whiskers, it just happened to work out that way. I had only 2 types, and there was that one property that discriminated based on it. If I've got 5 types, there might be overlap between them. There might be the same property name in 3 different types. This is not a scalable solution. It just worked out perfectly here, but what if I get some other animal in this that also has whiskers? I don't know, maybe a lion. Maybe I have a lion type and the lion has whiskers, and then the lion has some other lion properties. Now, if I narrow it based on whiskers, TypeScript is going to say, well, okay, now it's a lion or a cat. And actually, just for fun, let's code that up. Now that I say that, this is not on the instructor reference, but just for fun, I can do whiskers, deadly, and we'll just hard code that to true, because it is. And now it could be a lion. Now if I come in here, TypeScript is like, now I don't have my cat breed anymore. All I've done is I've narrowed it to cat or lion. So this is a very fragile solution, but it exists. I've actually used it at work one time in my life. It was actually a few months ago. This really comes in handy occasionally. All right, so that's the fragile solution. It exists. Know it. What's the real solution? How do we really deal with these unions? You might hear the term discriminated union. This stuff that we're doing, we're discriminating between unions. Discriminating meaning telling one apart from the other. We found a really fragile way to do that by just looking for a property that happens to be unique, and it happened to work out nicely. We shouldn't assume that's the case. Let's just make a property that is unique. These are our types, so let's just add a type here. I'm going to call it type, and I'm going to hard code it to be the string cat. The casing doesn't matter. I can call it, it's just a property. I can call it whatever I want. It doesn't matter. I'm going to use screaming case just to make it clear that this is a special property. It has no special significance. And I'm going to throw this type down here, dog. All this did was guarantee me that, so I need some single unique property that's always unique between the types that I can discriminate based on. So I just added it myself. And now we'll call this the first one. And now let's build a good version of this property, of this function. And now, instead of using that weird in operator that you've probably never seen, now I can just check type like a grown-up. And look, it even gives me autocomplete. Like TypeScript is saying, hey, if this is cat or dog, those are the only 2 options it's going to be. we'll choose cat, and now same effect. Now I've got all my cat properties in here. And then as before, else, it's a dog. And if I add a third in there, I won't be able to use the else. I'll need to keep narrowing it down. Any questions so far? If you get this, we're like 80% done. Yeah?
Can you do that? Because there could be another type that has the exact same properties as cat, but is a different type.
Yeah, or even a partial overlap, like we saw with the lion. The lion could have whiskers too, and then other stuff, and then you're like, okay, now I can't check with the lion. Now I can't check on whiskers. You're always going to be just checking for the right combination of properties, which is going to be fragile. You start adding other properties and types. With this, now we control it ourselves. We're just going to add that single unique property, and it's there, and it'll always work.
Seems so redundant.
It's a little redundant.
So in this case, you wouldn't use like type of like that property to check see if animals type of cat or.
That's a really good question. No, that doesn't work. Let's pin that for a minute. Let's come back to that. That's kind of a deep question. All right. I will come back to that. Okay. Let's see. Yes.
So let's say you have like a lot of types at this point, like then I have to add a type property to.
Yep. All right. Okay. Do you see this variable here? Let my cat. We have given it a name, which is a string. We've given it whiskers, which is a number. We've given it a cat breed, and the spelling is all the same. That's why I'm double clicking these. And we've given it a cat, and it lines up. And so let's create a variable, some cat, and we're going to type it as cat. And now I'm going to say some cat equals my cat. And TypeScript is structurally typed, right? TypeScript only cares about the structure of, yes, question?
So now that you've added the type, you have to also add the type every time that you declare a new cat, even though it is hard-coded as type cat.
Yeah, but you can add factory functions to sort of automate that for you.
Okay.
All right, TypeScript structurally typed. All it cares about is if the structure is the same. I created this variable very carefully, and I gave it all the cat properties. I even have this stupid type, and I even hard-coded it to the same thing. So this should work, right? And that rat bastard instructor lied to us. It's not working. TypeScript's like, no, this isn't valid. I'm not going to hover over the error because it's going to just give it away. But can anybody? This is one of those things. If you know it, you know it. This is one of those rare times in life when TypeScript's just going to just hold your hand and tell you straight up. Type name string whiskers number cat breed string type string is not assignable to type cat. Types of property type are incompatible. Type string is not assignable to type cat. So if you've seen that once or twice, the problem is, as far as TypeScript is concerned, this is just an object, and I can do mycat.type equals some crap, and that's perfectly valid because this is just a variable and it holds an object, and if we peek at this, it's got type string, but we don't want string, we want cat. We want this to be hard-coded as cat, and this can never change, and we want this to be invalid. And TypeScript gives us a way to do that. We can say, hey, TypeScript, do you see this here? This is not some random string that I just happen to assign cat to. Treat this as a constant. And that's how we do it. And now TypeScript is going to say, OK, this is now cat. The rest of these are strings and numbers and strings. But now, since you said that that is const, this property is now a constant cat. And now the assignment works. It makes that property immutable. And if I say someCat.type, now I can't reassign it, or TypeScript will yell at me. Type is not assignable to type cat. I said as const, and so now that is a constant cat. There was one first question here.
Yeah, so it looks like the difference is when you declared the type cat, you gave it that variable actual value cat, it kind of made it a constant.
Yes. On line 6? Because this is a type. This is not a variable. This is type cat. And so I'm assigning properties to this type. This type has a name, which is a string, whiskers, which is a number, and it has this type, which is the string cat, the literal type cat. And I've got Prettier yelling at me, and when Prettier is not happy, nobody's happy. Oh, I've still got this animal dot. OK, that's why.
Why did we not declare the cat as type cat when we did the let?
Just because I wanted to show you this. So this could be just some variable that exists somewhere that happened to not come with the right type. And that was your question, and that was the last question I thought I saw. OK. OK. Oh, that's perfect. Who asked me if you could use type of? That was you, right?
Yeah.
Cool. Hey, here's a fun thing, a fun interview question. Let's pull up JS Fiddle. Let array, and this is JavaScript, by the way. This is just straight JavaScript. What's that going to log? Yeah, you think it's object, but you feel shameful about saying it, but you're right, it's object. It's like, what the fuck? It's an array. No, it's object. TypeScript's like, surprise! Or JavaScript's like, oh, it's object. Yeah, if you want to check if it's an array, you do. And that's, TypeScript in JavaScript is pretty limited. No matter what you pass it, you're going to get string, number, object, undefined, null, Boolean, and as of 2015, you can also get symbol. That's it. That's it. Nothing more, nothing less. That's hard-coded into the language. The good news is that still can be kind of useful sometimes. So a few times before, we have said something like, let's have a variable of type string or number, and maybe it'll be a string, and maybe it'll be a number. We actually don't even know. Even at runtime, it'll be one or the other. We have no idea what this thing is going to be. TypeScript will never know. I could hard code it as 12, and TypeScript will still be like, oh, well, screw me then. OK, never mind. TypeScript is very, very, OK, TypeScript is hardcore about its inference, and it's very smart. So as of now, TypeScript is like, I have no idea what this is going to be. It's like the cat and dog thing. It doesn't know whether it's a string or a number, so it's only going to let me call things that exist on both, which is value of, toString, and apparently toLocalString, whatever that even is. How do we narrow it? We can't use the type discriminator. We can't just add a type string or a type number, because these are built-in things that are in the language itself. So who can think of a clever way to tell whether this is a number or a string? We can use type of, right? There's 7 different type of: string, number, null, string and number. Those are valid checks. We can say if type of thing is a string, well, now TypeScript will narrow it as a string. Else, all that's left is number. Let's add Boolean there too. It's not a string, so now it's a Boolean or a number. Else if type of thing, Boolean, thing dot, and now it's a Boolean. Else, it has to be number. That's all that's left. Number. Okay. There is one more form of this that I'd like to show you. There was a time in JavaScript history when classes were like controversial for some reason. It was dumb. They are what they are. Use them if you need them. Let's say you have some classes. I don't use them very often, but they come in handy sometimes. Let's say we have a few classes. And let's say I have let's say I have let x is an A or a B. And again, we don't know what it's going to be. New A, else new B. OK. So TypeScript is like x dot. Well, there's nothing in common. I'm not letting you do anything with this until we narrow it. And now you're going to say, OK, well, let's just add a type like we did. And that'll work. We could do that. Maybe we should do that. That'll work. But let's just pretend that we don't own these classes and that we can't do that or that we don't want to, whatever. There's one other way where we can narrow this. Again, it's a JavaScript thing that TypeScript's also aware of. Can anybody think of the JavaScript feature that we can use? Yeah, there it is. So now we can say if x instance of A, now TypeScript will narrow it as an A, else TypeScript knows that it's a B. So instance of and type of are these really neat things. They exist in JavaScript, but TypeScript is like hardwired to look at what you do with it. And it has these incredible features where it'll sniff out if you're using type of or instance of, and it will just adjust the type of a thing inside of those if braces. It's the only language I know of that does that. Swift has similar things. Swift has like if x equals x, which does something totally different, but same similar idea. But yeah, use those features to good effect. And I want to make sure I didn't leave anything off. Did I have anything else I wanted to get to? Yes?
So why can't we use that for our cat dog?
Instance of only works with class instances. That's it.
What about type of?
String, null,
Oh,
undefined.
built-in types.
Yes. All right. Before we take a break, there's a module that like doesn't even really count because you'll see. This is like 5 minutes. I just want to cover this, and then we'll take a break, and then we'll do the last module, and then there'll be time for you all to dive into whatever you want. What am I doing? Let's see. Come on. 1, 2, 3. All right, somebody asked me about React before. So this is RenderATL. This is a React conference. I'm sorry that React is just like a footnote in this, but if you want to use TypeScript with React, there's nothing to it, really. So we have these function components. Oh, sorry, that's the instructor reference. Here we go. And even this gives away too much. All right, let's say we've got this component here, and it takes these props, and we want to like type them like grown-ups because we're using TypeScript and we don't want to just YOLO our props and just grab these properties like the dark ages. TypeScript gives you this FC, which stands for function component. This variable is a function expression. So like before, I showed you, I can just annotate this function as FC. And FC is a generic type. It takes a prop of P. Remember I told you single variable names? This is the actual TypeScript typings for React, and it uses P. Anybody want to guess what P is for? Props. I pass it whatever props it takes. And you can do it inline if you want, or you can just create a props type. I'll do the latter, type props equals, what does this take? It takes a string, that's a string. It takes a num, that's a number. And it takes a handler, that's a function. And just like that, now you have autocomplete. Now you have your typings. There's one gotcha on there. Let's do it again. Type props, title, string. All right, so I've got an error here. It's saying, hey, property children does not exist on type props. This was a recent breaking change with the TypeScript types for React. There's a number of ways to solve it. We can use a helper called props with children, which is also in the typings. And we can wrap it like that. And now we get the children. I want to say more, but here's how you add typings to a React component. And now it's just TypeScript. It's everything I've already been showing you. Type unions, strings, numbers, whatever. Go nuts. Back there first.
Like I was saying before, you still use a declarative function as a component, but instead of having the FC, is the type to the right of the arguments or the prop, the structure props, right?
Yup. You absolutely can do this if you want. Nope, you can still, just like that. There's one disadvantage though. React has certain things that you can return from a function and certain things you can't. The rules have gotten looser lately. What are you not allowed to? Undefined. Can you return an array? Even that's valid now. Client components are async. But actually, you know what? Promise.resolve. Christ. When you do it this way, there's no validation on the return type. So if you do find something that's not a valid return value for a React component, this will. Oh, I did it wrong. Hang on. So let's go back to what we had before. Yeah, here you go. Return type validation. Props returning void is not assignable to that. If you do it this way, it will validate your return type. This expects you to return something. And I don't think a promise will be valid. Promise.resolve 12. Yep, cannot do a promise. That's why everything was working before, because it was a function declaration. TypeScript was like, whatever you return is the return type. You return something that's invalid. I don't care. That's not my problem. When you do it this way, that's why I always, always, always do it this way. Lots of people do it the other way. I prefer the return type validation. Any questions? Yep.
Syntax just like nested generics?
Yes. Okay. Generic types can take generic types, which can take generic types, turtles all the way down. All right, let's do a quick 5-minute break.
I'll get you after. I was
Okay.
about React element, or React node rather, for the children.
Yeah. Yeah.
In your props
Sure, we can talk. All right, take a quick 5. Let's come back at like 12:11, and then I got one more module. I really want to get some advanced stuff for you to take away, and then there'll be time for you all to do your thing.
Yeah, I was curious. Jacob, by the way. Great.
Hey, nice to meet you.
Matt Pocock. He just did that recent React TypeScript course, and he was talking about.
So this is the type. So you're creating a type. So the as const is something you do on variables. So I think what you meant to do was const.
Okay, because I was looking, but
Yeah.
I couldn't see why that wasn't. Okay, thank you.
Yeah, you bet.
Yeah, he talks about using just typing the children prop is React node.
That'll work too. But you're still
And you
not going
get
to.
the return.
If you use FC of and then you just add the children.
Instead of using it as a generic, he types props.
To take children of no type.
Yeah.
That's just more work. I mean, I'd rather use the thing they give you, but that's fine.
Gotcha.
That's, if you don't mind typing children, I'd rather use props with children. Whatever.
Gotcha.
They both do the
Yeah,
same
cool,
thing.
Just stylistic difference.
And in fact, I mean, there's no secrets here. You can. I just had. Oh, right. I mean, you can just go to definition. You'll see all it does. That's all this does. And really, it's React Node or undefined. Children can be undefined. So.
Right. Because undefined isn't part of React. Isn't React Node's definition.
I think this just means that children are optional.
Gotcha.
And that's why it's like that.
Oh, right. Because it's optional, you have to also return undefined.
Yeah.
Because
Yeah.
it should be undefined.
Either will work though.
Are you going to talk about infer? Because I'm still super
Yes.
confused about when to use it.
Yep. It's coming. Next. Hi.
Is it possible to sort of like slowly introduce TypeScript into your like React feature if it's already like
Yeah.
Are you able to just do it like in a file by file kind of
Mhm.
situation and it doesn't break everything else?
You'll need to make sure you configure a lot of things. Implicit any is going to have to be okay. Allow JS is another setting. You have to trawl through all the TypeScript config settings. But yeah, doing it incrementally would be the only real way. Yeah.
I come from using Ember, so that was a root.
Oh, goodness gracious, yeah. Yeah, definitely. tonight I'm keeping it classy and chill. Tomorrow night, bitch, you better. All right, welcome back, everybody. I hope this hasn't felt too fast-paced. I initially thought this was going to be like one workshop that was like 5 hours, and I had a bunch of exercises, and in between of these, it'd be just chill, you do some coding. But it was 3 hours, and then I kick you out, and I get a whole new batch. So I wanted to cover all this material. There'll be some time in a bit for you all to just check out any modules you're curious about. You can check out some of those exercises. A few slides to kick off the last section. These are advanced topics, but they are hugely useful to know, in my opinion, in my experience. This is a risky topic, but I'm going to go for it anyway. I'm going to try and teach you a little bit about variance, and variance means TypeScript asked you for some type, but you provided something that was different. And that can either seem obvious or crazy, depending on how you think about it. That's okay. These slides, or excuse me, when we get to the code, I'm going to use classes. But I need you to understand that this applies to any types. And I'm only using classes because it makes a few things easy. It makes some things familiar. Hopefully, it'll make things easier to see. Structural typing is in effect, just like always. Classes are very uncommon, in fact, in my experience. But again, these concepts apply to any types. And I promise this is worth knowing. There's two types of variance. There's covariance, which means you provide something that's more specific than what was asked for. You asked for a shape, but I gave you a circle, which seems fine. We're probably already familiar with that sort of thing. Contravariance is the opposite. You asked for a circle, but I gave you a shape. And that seems crazy, but sometimes you can do that. And then there's bivariance, which means both, and invariance, which means neither. I'm going to get to that in code. Structural typing interlude. TypeScript does not care about the extends clause in a class when it's matching types. When I say TypeScript is structurally typed, I mean it. Like, if you create one class and then create another that extends it, and you don't add anything, as far as TypeScript is concerned, they're identical, and they're bivariant. So some of the stuff I'm going to show you won't work. If you choose to use classes, make sure you always add some junk to the subclass. TypeScript only cares about the shape of the final class. It'll look at the stuff in the superclass, but if you don't add anything to the subclass, it'll treat them as the same, and I'll show you that in a second. We'll get to that. And we're going to talk about conditional types, and that's where somebody asked me about infer. That's where conditional types come into play. Not the most useful slides. Let's just get to it. This is going to get scary at times. If I lose some people, don't worry about it. Like I said, this is advanced stuff. I've got these classes here. I'm sorry to harp on this so much. If you don't like classes, don't worry about it. I'm assuming this is going to be somewhat superficially familiar for you, and it also gives me an advantage. I can just say new circle like that, and that's just really convenient. I can just spit out an object easily. In real life, this is uncommon, and in real life, you'll probably see something like this. You'll see something like that. And then you'll see like type circle equals shape and radius number. This uses a type intersection. I told you type intersections were less common. They're actually extremely common, but for something different. This is how you do like class inheritance in TypeScript usually. You say, I'm going to take this class and then I'm going to extend it with the and that's how you build something more specific. I didn't want to throw this at you. I thought this would be a little bit softer on the eyes. And like I said, also, I can just do that and create an actual object. All right, let's jump right in. Let's say I create a circle like that. equals new circle. And I don't need to annotate this, by the way. Inference is in effect just like always, but I want to. I want to be very, very specific. Like that. Let's say I create another shape. And let's say I want to assign shape 2. I want to assign a circle into shape 2. Do we think that's going to be okay? Shape 2 is a shape, and I want to stuff a circle into that. Yeah, of course it is. I asked for a shape, and I got a circle, but a circle is a shape. It's just a special kind of shape. That's totally fine. How about the reverse? What if can I do that? No. I asked for a circle. A shape is not specific enough. That's not going to work. Now let's get weird. Let's do some weird stuff. Let's say okay. I wrote some functions. I've got a function type here that takes a shape, and I've got a function type that takes a circle, and now I wrote some functions that implement those types, just like that. All right, so when you ask for something that's less specific, you can always assign something more specific, right? So draw shape. That takes a shape, right? I can assign something more specific. That's totally cool, right? Draw circle. You know what? Let's like that. Draw a circle. That's totally fine. Nope. TypeScript's yelling at me. Well, I certainly can't do the reverse, right? We'll figure out why that's failing. But obviously, if I have a draw circle, I can't assign something less specific, right? That'll never work. Things have reversed. So let's really try to tease this apart. And this actually will come up sometimes. This is one of those tricky, hard problems that if you sort of know these things can come in handy big time. So take a step back and just be kind of dumb for a second. So draw shape. This is a function that takes a shape. I'm saying this function has to work with any shape that I pass it. So it kind of makes sense. You can't give it a function that only works with circles. I'm saying, hey, this function needs to work with any shape. And then TypeScript's like, what the hell, dude? I told you this was a function that works with any shape. How can you possibly give me a function that only works with circles? This one, I'm saying, hey, give me a function that only works with circles. And then you're saying, bro, I got you. Here's a function that works with any shape in the world. And TypeScript's like, well, OK, that's more than I asked for. Cool. That's the hardest thing we're going to cover in the whole workshop. I got a few other things to show you. If you have any understanding of that, cool. I'm going to move this along. I just want to tell you, these are variables. Remember we saw the whole I can assign something more specific. That's the same with return types. If you have a function that returns a shape, you can substitute a function that returns a circle. That much should be intuitive to some extent. But feel free to talk to me about it. I want to get to conditional types. Here's where TypeScript gets super powerful. And it's all downhill from here. I front-loaded the hard part already. Type useless equals array of number. Here we go, something new. Extends object, oh, no quotes, object, true, false. And now we can hover over useless, and it's true. So this is a new feature. This is brand new. I have not shown you this yet. This is a conditional type. Oh, I was muted the whole section. I'll have to get the audio for this one on the version 2 of this. This is a conditional type. What we're saying here is I've got this type. Does it extend object? If so, then this type is going to be the true type. It doesn't have to be true. I can just put anything in here. Else, string, I don't know. And now it's going to be this val thing there. Does array of number extend string? Well, now I got the else here. Never is a common thing to put there. Now this useless is never. Okay? That's just silly though. You're not going to do that. I'm just showing you this so you can see the syntax. Let's get slightly less useless. Let's say type is array. Let's take a generic type of t, and we're going to say equals t extends array of any, or unknown should work, true, else, false. And now we can say type, I don't know, is array number. Number array extends array of unknown, true. How about just a regular number? Of course not. A number does not extend an array. All right. Let's try to be a little more useful here. Let's say array of what, right? It's going to take in an array. T extends, and I want this to return back. So if I pass in a number array, I want this to be number. If I pass a string array, I want to get string out. I want to extract the string out of it. So type array of what? T equals T extends array of whatever that is, return it. So that else, we'll say never. But that's not valid. I want to, whatever this is an array of, I want to just extract it out and then return it. Infer. That's how we do that. That's what the infer keyword does. That's how conditional types work. And this is just ungodly powerful when you start to do some more advanced things with it. Type array of what? T equals T extends that. Return it, else never. There is a big pile of type utilities out there. Let's say we wanted to get the return type of a function. We'll say type get return type of t equals t extends. Well, what if this is a function that returns, that takes any, I don't care what, and it returns infer u, return u, else never. Why are you yelling at me? See, this is why export default null. Shut up. All right. Get return type of, well, what about a function that returns 12? Or better yet, here. Let's say we have a function that returns 12, and now I want to extract the return type of it. I pass the function. Well, TypeScript's going to yell at me. This is a value. I have to pass a type here, so here's another use of type of. Extract the type of this function, pass it there, and now TypeScript is going to be good enough to pull the number out. T extends this function infer u. The good news is you don't even have to write that because return type exists in TypeScript already. And here's the really cool part. You can function F12, and you can actually look at these TypeScript definitions for these things. And TypeScript is pretty similar to mine. TypeScript adds this extends here because we don't want to be able to call return type with just a non-function. That fails with TypeScripts, but it works with mine because, like with the catalog item, TypeScript's like, whatever. Well, that, and now it'll fail on mine because we've narrowed it here, and now we use the conditional type. Really quick whirlwind tour. I do want to cover, I just want to show you some really neat things just so you know they exist. Let's say we have this type, correct life choices. I added this at the last minute. These are the correct life choices. Obviously, if you're coming to a conference, it should be this one. City, some natives already yelled at me for calling it Hotlanta, so I won't do that anymore. All right. This is a type. It's not an object. This is a type, and I put literal types in there. You know what? There's no correct, whatever language you're making money with is the correct language, so I won't pin that to TypeScript. So now this is our type. You can build your own types that are indexed arbitrarily. I'm just going to call this X for now. I'm going to call ABC. So equals. See these square brackets? This is an index type or a map type. I am saying this type ABC is an object that takes any key that's a string and holds a string. So it's pretty much any record of strings. You don't have to do just string. You can narrow it and say key S in key of correct life choices. And now it's a little bit more limited. Now we've got this type ABC. Conference is any string. City is string. It's inferring these as strings instead of, yeah, because I put string here. So how do we get the actual type from here? Well, we can say correct life choices of S. Let's use capital. And now ABC is, I just duplicated the type. I just sort of mirrored it. That's useful to know. These are those type indexes that I showed you before. What if, so this is kind of pointless, but here's the really neat thing. What if I want to rename these properties? I've got this type. Can I build a new type, but instead of those properties, can I rename them? So see these S's? This is S in key of. This is giving me conference city language. What if I want to create a new type that renames those? Well, those are template literal types. I can say as, and for now I can just do that. But I can do my own thing here. I can do that. And now look at that. It did get conference, get city. We want this capitalized though, right? TypeScript gives us a bunch of helpers that work on these template literal types. I can say capitalize S. And now, just like that, I've got get conference, get city. But these are getters, so we want them to be functions, right? Well, instead of mapping it to that, what if we map it to a function that returns that? Now we can do, this is meta programming. I can take an existing type and I can just sort of morph it to something different. So if you have one type and you need to project it to a bunch of functions, and by the way, check out the instructor reference if I'm moving too fast. It's got all this crap and like a bunch more that you may not even want to know exists. Here's a fun one. Just for fun, I'm going to be a language snob for just a minute, and I'm going to turn this back to TypeScript. Okay? S in key of. So this is a very common starting point. Matt Pocock talks a lot about this. This should just be, I've mapped that. Here we go. So this is a type. What if I want to pluck the values out? What if I want to get a union of just the values on this type? There's a neat trick where I can just index this. So you know how this is a type? I can say like city, and now I get Atlanta, right? What if I want to get all the values? Well, okay, I could do city or conference or language, right? Now I'm getting RenderATL or Atlanta or TypeScript. Instead of passing one string in, I can pass a union, and TypeScript will give me whatever those values are for any of the keys that I pass in. But what if I want to do that all at once? I can do things that matter and square brace it here to get the values. Or I can just do it in line here and just say key of correct life choices. And now things that matter is just that same union of all the values. Again, I'm moving fast. All these examples are in the instructor reference. I just want to give you as wide a swath of examples as I can. All right, last thing. I'm not going to type all this out. Nobody got time for that. All right, this is very much a real use case. Let's say you're writing a routing library. You're going to write like TAN-stack router. That guy's really smart, Tanner. Here are some paths for your web app. And I notice the as constant. I do not want these inferred as strings. I want them as actual paths. Well, what are my paths? Type paths equals type of paths. What's that going to give me? Nothing useful. So let's just strip out these values like I showed you. Let's say type all paths equals p in key of paths. Oh, that's it. Sorry. All right. Type paths equals type of paths. That's why I did that. Okay. All right. So this is the default. Remember I told you when you have a default object and then you can do type of to pull the type up. Here's a JavaScript variable. You're configuring your web app. Here's all the paths in your web app. Now I want to get a type of that. Here's the type. Boom, don't worry about the read only. Now let's just get a union of all the paths. I want the actual string paths. I want /users, union, /users context. Well, I just showed you how to do that. Paths of p in paths. key of paths. And now that gives me that union that we saw before, right? Here's a cool trick with template strings. You can use that infer with template strings. Let's build a type pluck path 4, and we'll do a T. I'm gonna just bail at this point. I want to give you guys 20 minutes to. This is some cool stuff. You can. They're not actual regex, and the way that this is ending, we would do like an infer u here, and then we would return the u. You can do some wild shit with TypeScript. Check the instructor. We got like 20 minutes left. You got to have some time to check it out yourself, or you can bounce if you just need to have a drink. That's fine too. I gave you a lot. Hopefully you got some useful stuff in here. Godspeed. I'll be here if you have any questions. Thank you.